In this question, you're asked to find limit n tends to infinity, n factorial power 1 by n by n. So we know what n factorial is, right? Limit n tends to infinity. So let us say that this limit is L. N factorial is nothing but 1 into 2 into 3 into so on up to n by n whole power 1 by n, right? So as you can see, you have a product of infinite number of numbers. As n tends to infinity, this n factorial has product of infinite different numbers. So I want to convert this product into sum. So what I do is, what I can do in this question is, let us apply log on both sides. So what is ln of L? So if I apply natural logarithm on both sides, you get limit n tends to infinity ln of, so what you can do is, I can write it as 1 into 2 into 3 into so on up to n by n power n whole power 1 by n. So the denominator n can be written as n power n whole power 1 by n. N power n whole power 1 by n, which is same as n, and 1 into 2 into 3 up to n whole power 1 by n. So we know that the power inside log can be brought outside. That is equal to limit n tends to infinity 1 by n into ln of 1 into 2 into 3 into so on up to n divided by n power n means nothing but the product of n taken n times. So I can write as n into n into n into so on into n. So in the numerator you have n different terms. In the denominator also you have a product of n terms. So now we know that log of a into b is log of a plus log of b. So using that property, what I can do is limit n tends to infinity 1 by n times. So this can be written as log of 1 by n plus log of 2 by n plus log of 3 by n plus so on up to log of n by n. Now this looks like a summation. This looks like a summation. So I'll try to convert this into a sigma notation. That is equal to limit n tends to infinity 1 by n sigma r is equal to 1 to n ln of r by n. This r is going from 1, 2, 3, so on up to n. The denominator is always equal to n. So 1 by n sigma r equal to 1 to n ln r by n. So this is ln of n, right? So now as you can see, this is of the form limit n tends to infinity 1 by n sigma f of r by n, r going from 1 to n. So we know that this is equal to integration 0 to 1 f of x, right? So this becomes integration 0 to 1. F of x means wherever you have r by n, you just need to put x. This ln x dx. So what is the integration of ln x? We have already done this using integration by parts, right? So the integration of ln x is x ln x minus x, going from 0 to 1. So now you have a slight problem. So now what you do is you just try to substitute the limits here. So what is the upper limit? 1 ln 1 minus 1. 1 ln 1 minus 1 minus, what is the lower limit? 0 ln 0, 0 ln 0 minus 0. So if you closely observe this numbers, so 1 into ln 1 is equal to 0, so 1 into 0 is 0 minus 1 minus. So 0 is okay, but here you have a problem. 0 is okay, but ln 0 is minus infinity. So 0 into ln 0 is not defined. So sometimes the function that you get on integration will not be defined at the limits. So in such cases, what you need to do is you need to find the limiting value. That is, exactly at x is equal to 0, this is not defined. But as x goes close and close and close to 0, so where does x ln x go? So that's what you need to substitute here instead of 0 ln 0. So limit x tends to 0. As x goes to 0, where does x ln x go? So what is this limit? So this limit can be found out using L'Hospital rule. That is equal to limit x tends to 0 ln x by 1 by x. As x tends to 0, this goes to minus infinity. 1 by x also goes to infinity. So I can use L'Hospital rule. I can differentiate both the numerator and denominator. So that is equal to limit x tends to 0. What is the differentiation of log x? 1 by x divided by, what is the differentiation of 1 by x? Minus 1 by x square. So x, 1x gets cancelled, x goes up. As x tends to 0, what is limit x tends to 0 minus x? Answer is 0. So this value has to be substituted as 0. Exactly at x is equal to 0, the function is not defined. Hence, I just need to see what happens to this at the limiting value as x tends to 0. So the answer is minus 1. So this is equal to minus 1. So ln of L is equal to minus 1. Ln of L is equal to minus 1. So I need the value of L. So ln of L is equal to minus 1. This implies L is equal to e power minus 1 or 1 by e. So this is the answer to this question. So this limit is equal to 1 by e.